Hello class, today we're in 5.4 intervals of rational functions. So far with rational functions, we've talked about its domain, we've talked about their x and y intercepts, and we've talked about the asymptotes. But now we're going to talk about intervals, we're going to talk about decreasing and increasing intervals of rational functions. So we've looked at increasing and decreasing intervals before, but not with rational functions. So just a reminder, when determining intervals of when a function is increasing or decreasing, we always read from left to right. So just like how we read a book, we always read a function from left to right. If the function is going up, it's increasing. If the function is going down, it's decreasing. And maximum and minimums separate intervals. So what are maximums and minimums? Well, maximums and minimums are the highest point of a function in an area and the lowest point of a function in the area. For instance, this point right here would be considered a minimum. And notice that it separates the decreasing side from the increasing side. Now, this only has one minimum, this particular example. So let's just verify that this is decreasing and increasing. So, reading from left to right, this is going down, it's going down, 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 awesome. And then it jumps up here, but it's still going down, isn't it? Although it jumps, the interval, although it jumps, it's still decreasing, isn't it? And it decreases, decreases, decreases until we get to this point at x equals 2, and then it starts increasing again, and then jumps down here, but it's also increasing over here, and it increases out this way forever. So how would we write that? Well, we want to write it as an interval, just like how we would write, say, a domain, right? From this x value to this x value, right? Right in the middle here. So let's see. The increasing interval is, well, let's start with decreasing first, because this one starts with decreasing, right? So it decreases from negative infinity in the x direction, right? So this is the left is the negative infinity in the x direction. And it goes and it decreases, decreases. It's still decreasing even though it jumped, and it's decreasing right until we get to 2. So it decreases from negative infinity to 2. And then when is it increasing? Well, right at negative 2, right after that, it starts increasing again. And it increases towards infinity. So it increases from 2 to infinity. So that's how we're going to write that. Let's look at a couple more examples here. We will also see some rational functions that look like this. And notice I don't have a dotted line going down here like I do here, because the dotted line in this case is separating the decreasing from increasing intervals. But notice if we read from left to right, this thing is always increasing. So starting here, it's going up, it's going up, it's going up, and then it jumps, but it's still increasing, isn't it? And then it keeps going and it increases forever. So we could say that this increases from negative infinity to positive infinity. And then we have to ask ourselves, is it decreasing at all? No, there's not. There's not a point where it's decreasing. So we can just write NA, or you can write not decreasing, something of that sort. And also notice that this function doesn't have a maximum or a minimum anywhere, right? Unlike this one doesn't have a max or a min. There's not a point where it goes down on both sides of a point, or it goes back up on both sides of a point. And then we've got this one. This one's a little more complicated. Now here we have 2 dotted lines, and we have 2 max/mins. So here, although it doesn't really look like it, we have a max right here. It goes down to the left and it goes down to the right. Now, sometimes with rational functions, you will get a minimum out here somewhere or out here somewhere. In fact, many times you will. So be careful and look for those. But they're so flat, it's hard to tell that they're there. And I'll show you how to find them on Desmos in just a moment. So let's see, reading from left to right, it looks like this is increasing until we get to this maximum right here, and then it begins decreasing, and then it jumps, but it's still decreasing, and then at 2, it goes back up, jumps, and continues to increase forever. So let's talk about the increasing. It looks like we have 2 increasing intervals here. So we're just going to write it as separate intervals. Let's see. So it increases from negative infinity all the way to the left up until negative 4. And then it decreases, but we'll talk about that in a moment. And then when does it increase again? Well, it looks like it starts increasing at 2, and it increases for infinity. So we'd say from 2 to infinity. And then we think about our decreasing interval. Well, that's the interval right in the middle, right? Isn't it decreasing from negative 4 to 2? Yeah. So decrease from negative 4 to 2. And that's how we write it. So let's now take a look at these problems using Desmos, because that's what we're going to be doing today. We're going to be we're going to be typing in these equations into Desmos and graphing them, and then we'll be determining increasing and decreasing intervals that way. And Desmos is really nice because it actually shows us where maxes and mins are, just like how it shows us where the x and y intercepts are. So let's take a look at this first one. F of x equals x squared minus 4x minus 3 divided by x squared minus 3x. So I went ahead and I graphed this function for us. And here you can see, let's see if I can make this a little brighter. Not really sure how, to be honest. Okay. So, but it's bright enough. Okay, so if you click, I know this is different because I'm going to touch it, but on your computers with your mouse, if you click the function, notice that little points come up. I have a point here, point there, and a point there. And let's scroll over here. There's no other points. Okay. So the points that it gives us are, it gives us x and y intercepts, and it gives us maxes and mins. So if you see a point at a spot where it's not an intercept, it's a max or a min. So looking here, this point right here, this is going to be a max. It's hard to tell because it's so flat, but if we go to the left of it, it's going to be decreasing. And well, it's going to be decreasing from this point, right? So it's actually increasing if we read from left to right. And then after this point, it starts decreasing. So this is the highest point. So let's see here. When we're talking about intervals, we're talking about just the x value. So ignore the second value. So the increasing interval here, is from, let's see. Well, it starts increasing from the left from negative infinity to this point right here, negative 7.243. And if you notice, a lot of these won't be perfect numbers. There'll be a lot of decimals and stuff. That's just how the nature of these rational functions. And so from here, it starts decreasing. So it decreases and keeps decreasing. This point right here is just from the intercept. And then it's decreasing still. And then it gets to this point, this minimum right here, and it begins increasing again. So it increases from negative infinity to negative 7.243. But then it also increases after this point from 1.243 all the way to positive infinity. Now the portion in the middle is where it's decreasing, in between where my index finger is and my pen is, between these 2 points. So it's going to be decreasing from negative 7.243 to 1.243, just like that. So let's take a look at a few more examples here. My camera's going wild. Okay. So now I have graphed this one. And if I zoom out here, this looks like one of those cases, and I press this, and I'm not getting any points here. The only points I'm getting are right here where this is the, if I zoom back in, the points I'm getting are the x and y intercepts right there. So this one doesn't have any maximums or minimums. So this one is actually increasing the whole time, right? Starting from the left, it's going up, and slowly it's going up, and then it starts going up really quickly. And then over here, it jumps and it keeps going up and up and up forever. And then it continues, it levels out, but it's still slightly going up, very slightly. So this increases from negative infinity to positive infinity. And then it decreases. This doesn't decrease ever, this function. So looking at this next one, x minus 3 over x plus 4 times x minus 1, I have it graphed here in green. And let's see if there are any maxes or mins. I know there's one right around here, but I'm not sure if there's one over here or over here. And there you have it. Let's see. This is a slight max right here. So, and this is a min right here. These two are our intercepts. So let's see here. I'm going to zoom out. So it begins decreasing, right? And it decreases, 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 and then it decreases, decreases, and decreases up until this point right here at negative 0.742. So it decreases from negative infinity to, negative 0.742. And then it increases from that point until this max over here. So it increases from this negative 0.742 to the 6.742. And remember, we're just looking at the left numbers. We don't want to look at our y values. We're just talking about x intervals here. So negative 0.742, comma, 6.742. And then from that point on until infinity, it starts decreasing again, because it's on the other side of that max. So we can say from 6.742 to positive infinity. Remember, positive infinity is going to the right. Awesome. I've got a couple more examples here. So now I have graphed this function. And if we were to look at its graph, it looks like there are two maxes and mins, right? There's one right here, and there's one just to the right of the y-axis. So, let's see. Starting off from the left, it looks like it's increasing until we get to this point right here. So it's increasing until negative 2.414. So from negative infinity to negative 2.414. And then it begins decreasing from 2.414. And even though it jumps, it's still decreasing, right? Until we get to, oh, I didn't mean to do that. Until we get to this spot right here at 0.414. So it decreases from negative 2.414 to 0.414. And then from that point, it starts increasing, as we can tell. So it increases from the 0.414 all the way to infinity. All right, and then we got one last example here. And here we have the f of x equals x squared minus 2 plus 3 divided by x squared. And if we just zoom out, let's kind of see what's going on here. So it looks like it's going up and then it comes back down. I'm not really sure what the nature is over here. So let's go ahead and click the function. And you see there's a minimum right here. It's actually increasing from this point onwards to the right. So let's see, we don't have one on the left. So it looks like the left side is just always increasing, and it looks like it's increasing until we get to 0. So this is increasing from negative infinity to 0, because the axis is 0, right? And then it begins decreasing from 0 to that point, the 3. So it decreases, a nice number. Oh, not positive infinity, to 0. Sorry about that. Hopefully you caught that. And then it decreases from 0 to 3. And then it increases again from 3 onward to infinity. And that's that. So Desmos is a very important tool, very useful when dealing with graphs. The best part about it is it gives us the points the points in between the intervals. It gives us those maxes or mins. So this is all I have for you. Get started on the worksheet. Let me know if you have any questions, and have a good day.